Let's take a look at the questions on homework number 19. First, we'll determine if a set of points is a function. Remember that the definition for a function is that each input can only have one unique output, or no repeating x values with different y values. We're looking for a relation that is not a function. So anything with a repeating x value and a different y value is not a function. Here we have a repeat and different outputs. So you cannot have an input of -6 and an output of 5 and 3. So this is not a function. Again, you're looking at the x values only, determining whether it is or is not a function. This one is looking for the one that is a function. This one has a repeat. This one has a repeat. This one has all unique values. This one has a repeat. So we found our function. Let's take a look at the second topic on average rate of change. In these questions, you'll be asked to find a rate of change on a graph. So we're looking for the average rate of change that is the smallest. So that means that is the one that is the least steep. Right? So I'm looking at this one's pretty steep. This one's definitely less, so I can just tell visually. These look very similar, but not the same. This one looks slightly less, so I'm just sort of eyeballing it. But I'm going to compute the rate of change for all three of these sections. Remember, the rate of change is the delta y over the delta x value. So here we go. Over here we're going to get 27 minus 16 over 11 minus 3. Up here we're going to get 45 minus 27 over 26 minus 11. And right here we're going to get 51 minus 45 over 40 minus 26. And you're going to pick up your calculator and compute. So I used my calculator to complete each of these average rate of change fractions. And it looks like this top interval, from 26 to 40. From 26 to 40. It's the x interval. Okay, let's take a look at the third section. Solving for a specified variable here. So I want to solve for a, which means I want to isolate the a value. So first, I'm going to subtract g from both sides, giving me d minus g equals a divided by 6. And then I'm going to multiply both sides by 6, the entire side by 6. And that will leave me with 6 times the quantity d minus g is equal to a. And that's what I'm going to type in the answer field. 6 parentheses d minus g, and we'll submit. One more time. We want to get the letter lowercase b by itself. I'm going to move this entire, oh no, let's see here. There's a b here and a b there. And they're not like terms. So what we want to do is focus on getting both of these b's into a single b. We're going to do that by factoring. We're going to remove that letter b from each of these products, and then we're going to state what was left behind. And after we factor, then we can isolate by dividing by this quantity here. So 2f squared divided by the quantity g plus n. Oops. 2f squared divided by the quantity g plus n. All right, let's take a look at the fourth topic on graphing inequalities. So in this topic here, the first thing you're going to do is start by graphing the y-intercept. Follow the slope one time, rise -2, run +3. Choose your boundary line. This one will be dashed because it's a greater than sign. We're going to shade it to the up direction because it is greater than. If you want to change it, click it more than once. One more time. The inequality must be in slope-intercept form. So I'm going to isolate my letter y by manipulating the equation here. And it doesn't matter what order I put my terms on, but it does matter that my y has to be positive. And if I divide by a negative, then that means I reverse the order of the inequality. So I'm going to graph 5 plus x, starting at 5, and rising 1, running 1. And it's a greater than sign, so that means it will be dashed, and it will be shaded above. Alright, next topic is on solving systems graphically. It will be drawn for you. You simply have to identify that solution point using parentheses and the correct coordinates. So I can see here that this system intersects at this point here, -1, -1. One more time. Identify the solution to the system. Type those points as a coordinate, and submit. Last section, identifying the solutions from a quadratic linear system. So I can see that my parabola and my linear function intersect 2 times, and they intersect at the following coordinate points: 4, 2, 4, 2, and 9, 7. Type it in and click submit. One last time. Identify the 2 points of intersection, here and here. Write those coordinates in the answer box. The first one is 2, 4, and the next one is 7, -1. That concludes the video for homework 19.